All right. So here we go. Formula you should write down. It's a very general formula, and that won't be enough room. That means height at any given time. That's what that stands for. The height at any given time. So T obviously is the time, H is the height. You can use 1/2 G T squared. Obviously you know the T is time. We'll talk about the G in a little bit. Plus, you can do this a lot of different ways. This other one, I normally do V sub 0, some do V sub I. Whatever you want to do, it doesn't really matter. V sub 0, V sub I. Times time. Plus initial height. This is for a free falling object. Yes, this has a lot to do with physics. This particular formula you see in this example actually used that formula. Let's see if we can figure out how that formula up there came from here. Because obviously h sub I means initial height. H sub v is initial velocity. T is still just time. T squared is time squared. G, I said we'd talk about that in a second, and we will. So h of t equals, let's kind of fill it in backwards. Do we know the initial height in this problem, that example that we have? Does it say there was some projectile, initial velocity of 256 feet per second, initial height of 576 feet? All right, so that's 576 plus, right? There's some t. It says initial velocity of 256. You will learn that that means it started going up. Because obviously if I'm at 76 feet up in the air, could it possibly start going down? Could I throw it up or down if I had something? I could, right? This one happens to be going up because it's a positive. Okay? If I said I threw it down, then it would be a negative. Okay? But it is a positive, so we'll say positive 256t. Now, where did the negative 16t squared come from? Obviously, we know where the t squared came from, right? It's right there in the formula. The negative 16 is of interest. Normally, in front of these, you will either see a negative 16 or a negative 4.9. One of those two numbers will be out front. You have to decide which one. Well, g is basically the acceleration due to gravity. In gravity, if I threw it up as positive, then gravity must be pulling it down, which we would consider negative. Okay? So it is a negative. Now this one talks all about feet, correct? So that's why we're going to use it. It's negative 32 feet per second squared is the acceleration due to gravity if you're doing feet per second squared. So why isn't a negative 32 out front then? How come it's a negative 16? The half, right? 1/2 negative 32 is negative 16. So did I come up with that formula properly for this problem given the initial conditions? Yes. Okay. What is the other alternative for gravity that's acceptable that sometimes people use is more of a metric setup. And that's meters per second squared, right? But am I going to use meters per second if all of these are feet per second? Well, no, you're not going to use that. But if you want to, does anybody know what it is, meters per second squared? 9.8 and technically negative, right? Because we're saying, we're pretty much saying here that going up is positive, going down is negative. Believe it or not, you do have to stipulate that. Which way is what? All right? And so there you go. So now that we've gotten through that, my suggestion to you is use this formula. Your book is going to give you a different formula for almost every different problem. Why not just have one that just works? Instead of having several ones that I think they technically do one of them wrong because they forget to give you information. Okay? So use this. So the key are, figure out what gravity you need. It's one of these two. And how do you tell? Look at the label. What do they give you? What goes here? Initial velocity. Please realize initial velocity can be either positive or negative? How do you decide? Which way was it going originally? Was I throwing it up or throwing it down? Down is negative. Up is positive. Initial height, let's face it, that's always going to be, you're up somewhere. So that 0 is the ground, and you're up somewhere, right? Maybe on a cliff or in a plane, on a ladder, who knows? Or somebody just threw you there. I don't know. So really, finding that formula was not the question, was it? The question was, when does the projectile hit the ground? So when means I need to solve for time. So t is something I don't know, correct? So if t is something I don't know, so I don't know that and I don't know that, right? Or in other words, that or that. If I don't know either one of those, I better know this one. Do I know the height at the time I'm being asked about? I don't know what the time is, but do I know what I want the height to be at that particular unknown time? Somebody's saying 0. How are you getting 0? Yeah. I want it to hit the ground. Do I know how long it's going to take to hit the ground? But do I know what height the ball is going to be at when it does it? It's going to be at height 0. Okay. So what we're going to do is replace h of t with 0, because the height at that unknown time is 0. Well, look at that. That is quadratic. It's as though it magically happened in this problem. Okay? Ah, very good. That was me seeing if you were paying attention. Because some of you really weren't for a while there, for about 5 minutes, some of you were not. Okay? So very good. It is negative 16, positive 256, and positive. Now, could you do quadratic formula on that? E equals 0. You can, can't you? Those are some pretty big numbers, though, aren't they? That would take a while. I know some of you on your 83s or your 84s, you actually have the quadratic formula just built in. You have to type in A, B, and C, and it just solves it for you. Okay? But no, you actually have to put it on there or create the program. It's a pretty simple program to write. But isn't there something I could do before that to make the number smaller? Does everything divide by 16? Does it? Let's find out. Well, 16 obviously does, right? 256 does, because that's 16 squared, right? How about 576? Does that divide by 16? Does it? Perfect. Okay, so let's divide everything. And when we say everything, we mean everything, right? So 0 divided by 16, that's 0. Now, could we divide by negative 16 if we wanted to? Why would you want to do that? It makes that t squared positive, right? But if you're using, are we going to use quadratic, or what do you want to do? If we're using quadratic, does it really matter? Not really, right? So do you want to do positive 16 or negative? It's your problem. Positive. All right, so we're going to make this a negative t squared then, right? Plus 16. Now, do you have to do what we're doing here? No. You can do it the other way. It's just going to have huge numbers. I think they're going to be big enough as it is, aren't they? Plus, what did you say it was? 36? Now, you only want to do that if it actually divides out nicely. Or because, you know, I want exact answers here, and there's no guarantee that this is going to work out nice, is there? Not really. So now if we're doing it, we know A is negative 1, B is 16, and C is 36. Well, we better go to quadratic then. So really, in quadratic now, t equals all of this stuff, right? Because that's our variable, not x. T equals all this. So what do you do first in quadratic? The opposite of b. So b is 6, so it would be negative 16 plus or minus the square root. B squared. Well, we go back to 256, right? Everybody's good with that? Any questions on the 256 there? We took b and squared it, so we got right back to 256, right? Minus 4 times, careful, a, very good, times 36, which is c, all divided by 2 times. Now here's where people mess up. They do all this great work and they do this. Yeah, you have to be very careful. That's why some people always make a positive, because they know they're going to mess up. Okay, so they plan ahead, right? And it's fun. You come up with the same answers. You don't have to worry about it, right? So we'll go over here. T equals negative 16 plus or minus the square root. Well, we got 256. Now remember how I look at this portion. You can look at that portion however you want. But I look at that and I say, let's just figure out what's the sign going to be in the end. Negative, negative, positive. If you multiply that together, you're going to get positive. Okay, so then that's how I do it. And I say, all right, I know it's 256 plus something, right? So 256 plus, well, what is 4 times all that there? 4 times 36? I think it's 144, isn't it? Right?
Yeah.
All divided by -2. I'm going to switch colors just so you can kind of see what I'm doing. I know it's getting kind of low. Sorry about that. I suppose I could go up there, huh? Let's do that. We'll go up to the top. All right. P equals -16 plus or minus. What is 256 plus 144? Is that a good number or a bad number to have in there? Yeah, that's not bad. Right? We'll take 400 divided by -2. Any questions of where the 400 came from? No? All right. So it equals -16 plus or minus what, real? 20, right? That's what the square root of 400 is? Over -2. So had we done the discriminant, it would have been, you know, with our problem down here, the discriminant would have been 400, right? And we would have said 2 real, right? And so we got -16 plus 20 is a positive 4, correct? Positive 4 then has to be divided by. So I get an answer of -2. So t could equal -2. Or -16 minus 20 is -36 divided by -2 is 18. And you actually know the label on both of those. It's time. Time has always been given in what here? Seconds. So it hits the ground twice? Okay, so why is that answer in here then? If you can't hit the ground at -2 seconds, that'd be going back in time, right? So either I picked it up from the ground and I got to 576 feet in the air really fast, all right? Or something's weird. Because -2 seconds doesn't make sense, right? So the answer, you're right, is 18 seconds, but I think we better clarify why that answer is in there in the first place. Why do we get 2 answers? Let's think of that. Okay, plus or minus. It is quadratic, so we know sometimes you get 2 answers, right? So I'm trying to figure out why does that -2 make sense? And can I erase this left-hand stuff so I can kind of show you why it makes sense? Everybody's got that down? Let's hope it works today, right? It wasn't working the other day. Let's say 576 feet's up here, right? Let's say this is time. So as time goes over, the position changes, right? We know at time 0, it's at 576, right? We know at time 18 seconds, it's where? At height 0, right? Isn't that what we just solved? And apparently over here at -2, it's also at time 0. Is that possible? Come on, somebody get it. How come both answers are there? Yeah, why do you have to plus or minus it? What's the graph of this look like? Parabola, which hits the x-axis twice. And did I initially throw it up according to velocity? So does it make sense that eventually it will, as time goes on, will come back down? Because at this point, at that point right there, what took over? Gravity. Gravity said, good try, you threw it really hard, but not hard enough. It's coming back down. So a lot of physics can be done in different ways. So when you get to your homework, should you use the formulas that the book give you for problems like this? No, use that one. Now, I'm going to give you a little hint on one of the problems. One of the problems says that a batter hit the ball. Obviously, is the batter going to hit the ball at a height of 0? We'll say it is, though. Okay, we'll say that the 3 feet's negligible. Don't worry about it. If you really want to get the answer, you can use maybe 3 feet up in the air. Your answer's going to be different than mine, but if you want to be that exact, I don't think it comes out very nice if you use 3 feet or something like that. We'll just say it's 0 that he hits it from. Okay, close enough. Okay, so don't work any more than that. This second problem, completely different. That formula is not going to work that I gave you on this page because this page has it for a free-falling object. This object is just wrapping paper. It's not falling. It's just wrapping paper. All right. So we have a rectangular piece of wrapping paper that has a perimeter of 50 inches. It apparently can have an area of 136 square inches. State the dimensions. Let's face it, guess and check could possibly work, right? But there is also a chance that I picked one that the dimensions are horrible. It came out to a quarter or a half. I didn't do it for this one, but I could have, right? Does quadratic formula really have problems with halves and quarters and stuff like that? No, it just comes out in the end, right? If you guess and check, could that possibly be a problem? It could. Again, this one comes out nice, but that's just because I didn't want it to be that much of a problem. So let's see how you could do this problem more algebraically, other than guess and check. So here we go. Width, now we'll do cursive so you can see length. Otherwise, it just looks like a 1. Right, so we'll say length here, width there. Agreed? It never hurts to see how to do these algebraically. Well, what are we talking about here? We've got some perimeter and we've got some area. All right, well, let's review those. How do you find perimeter of a rectangle? Kind of add them all up, right? So basically L plus W plus L plus W. So in other words, 2L plus 2W, right? Agreed? And then we also know that for an area, we take length times width. So we know those two. We also know in this problem that we want this formula to end up equaling how much? 50, right? Because it says the perimeter is 50. And we would like this other formula to end up equaling, what, 136? So basically, I replaced the P and the A with what they should be. Well, that's 2 equations and 2 unknowns. That's a system of equations, which we learned 2 chapters ago. Unfortunately, we can't really use matrices on this one because it isn't set up right. But we can use either elimination or substitution. But elimination is the one where you're supposed to add the 2 equations together. Does that look like that's going to probably work out too well for us? Probably not. So we have to use that other method, which is substitution. But in substitution, one of the variables has to be solved for. Is either one of those variables solved for down here? And it's probably easier to solve for one down here. But can I get one of them alone down here? Yeah, L times W equaling 136. How can I get either the W or the L out of there? It doesn't even matter. Which one would you get out of there? Which one do you want to get out of there? L, get L out of there? L, agree it cancels? That looks like an E. That's terrible. But anyway, W equals 136 E that's supposed to be an L. All right? What that means is anywhere else in this problem where I see a W, I can replace it with what? 136 divided by L. Well, I see a W right there. So let's replace it. This is substitution. So let's go up this way. So it's 2L plus 2. And what did you tell me that W could be replaced with? You just told me 136 over L. I'll do better this time. Not by a whole lot, but it is better. Equals. What, 1 million? I mean, what does it equal? 50. Very good. That was me seeing if you're following what formula I was working on. Well, wait a minute. We went from 2 equations with 2 unknowns. Yeah, sorry, it's so low. How many equations do I have now? I only have 1, and do you agree it's all the same variable? Well, that's a lot easier. Let's say you know this has to end up quadratic somehow. because otherwise why would we be talking about it? How are you going to solve this? Have you ever had to solve something like this before? Well, that divide by L is kind of a pain, isn't it? How are you going to get rid of divide by L? Multiply everything by L. Okay? So this term right here, guess what? We're going to multiply it by L. This we're going to multiply by L. This we're going to multiply by L. So what's this first term is? Oh, there's your quadratic. Plus, what can I do with these L's? They cancel, don't they? Well, that's kind of nice, right? Divide by L, multiply by L, at least that goes away. That was our goal anyways, right? What do we got there? 2 something. 272 equals? Why would you minus the 50L? Because we want to use quadratic, we want it to equal 0, right? Okay. So let's subtract. Is everybody caught up? I'm kind of going fast. Everybody's good? Okay. Subtract 50L. It's either that or you're all way ahead of me. I don't know. So it's, whoa, wrong. That's way too close to the other stuff, so we'll change colors. 2L squared minus 50L plus 272 equals 0. Why did I choose to kind of throw that negative 50L in the middle? Yeah. Exactly. There's your A, B, C, right? Do you have to put it in order as long as you know which one's A, B, and C? No, but is it pretty easy to pick the wrong one if you're not paying attention? Probably pretty easy, right? Oh, there's some in there. Once again, there's something I would do first. Yeah. Can we divide everything by 2? Makes our quadratic numbers a lot smaller, right? Yeah, why not? Divide by 2. So L squared minus 25L plus, right back to the 136 we had, right? Equals 0. So A equals 1, B equals negative 25, and C equals 136. Now that you have that, I would like you to try that. I will pause this for a little bit here and walk around and see how you're doing. All right, we're back. What'd you come up with? You got 2 answers, right? How'd you get 2 answers? It's L. Okay, so you got 2. Can I erase some of this somewhere? Or how about just stuff down here, maybe? I don't know. Well, I want to use that picture, so I'm not going. So you found out that L is equal to either 8 or 17, right? And if you didn't get that, make sure you stop in. We can go through quadratic. We'll take care of it. But wait a minute. Whoa, whoa, whoa. Once again, 2 answers because it's a parabola. Does that parabola really know what problem I'm trying to solve? No, I'm asking that parabola to basically find out where the roots are to that parabola. It really doesn't know what I'm trying to solve. So the strange thing is well, let's put 8 in here for L. That means that's also 8, correct? So we've used up 16. So if how much is left? If 50 is all the way around and I've used up 16, 34 is left, right? So it's telling me 17 and 17. Does that actually multiply to be 136? It does. So 8 works, right? 8's good. Well, does 17 work then? Because that means you just put 17 here and here. Means 34 is used up, right, of the 50. Means 16's left, so then the 8 goes there and there, right? Was there any stipulation saying one was bigger than the other? No, it didn't say the width was bigger than the length. It didn't say any of that, did it? So is it very possible that both are correct? It is. So either your dimensions are, well, just put 8 by 17 because then you're covered, right? So sometimes, like this example, quadratic mistakenly gives you both answers. And you weren't even looking for both. And then sometimes quadratic gives you answers that don't even make sense back in time. But you have to keep in mind all it is a formula or a function that has 2 roots. That's all it knows. Yeah, you might be solving some complex problem like this one, but it doesn't know. Okay? So any questions about quadratic and applications of it? All right.